Good afternoon, dear student. This is Professor Meenakshi Pancha, Electronics and Telecommunication Department, Parvatibai Gyanba, Mujay College of Engineering, Pune. So, welcome again to my subject, Microcontroller. Today, we are going to discuss the port structure of 8051 microcontroller. So, let's start. Okay. So, today we will discuss about brief details of port structure, how the ports are organized for input and output operation. We have already know about the pin diagram of 8051 microcontroller. There are totally 4 ports, how the ports are organized and what are the internal structures of port we will see today. So first we start from port 1. The number of the microcontroller has 4 ports named as P0, P1, P2, P3. Here P0, P1, P2, P3. There are 4 ports. All these ports are bidirectional and 8-bit ports. All the ports are bidirectional. All the ports are bidirectional and 8-bit ports. Each of these 8-bit ports consist of D type of output latch and output driver and input buffer. All these ports internally having a architecture or the system like a D latch, output driver and input buffer organization. All the ports upon the reset are configured as input port. If all the ports are reset, means we have configured as 0, then it will act as input ports. As the functions are multiplexed on the same port in order to decide which function is supported, we need to see how the circuit is connected and what software command are used to program the pins. The 4 ports are required for I/O operation. How many? There are 4 ports. There are 4 ports are required for the I/O operation out of 40 pin. See here the pin diagram. Here 1 to 40 pin. There are a total 40 pin in which 32 pins are set aside for the 4 ports. 32 pins are organized in 4 ports. This is port 0. This is port 1. Port 3. And this one is port 2. Total 32 pins are assigned for 4 ports. Each port take 8 pins. Particular ports having total 8 pins. The port 0 consists 8 pins. Port 1 consists 8 pins. Similarly, port 2 and port 3 consist of 8 pins. And each port is an 8-bit port. Each port is an 8-bit port. 8-bit port. When 0 is written to a port, it will become an output port. When in this port we have written 0, 0, 0, then these ports will be act as output port. To make it an input port, one is need to send these ports. If we have to act these ports as an input port, we have written to 1. We should make these all pins high. High signal should be provided these pins. Then these port will act as an input port. So let's see one by one. how the internal operation have to be takes place to act as input and output. So first see from port 1 because it's quite easy to understand the operation, and after that we will go for port 1 structure. So first of all, this is the internal organization of each port. Each port consists of such type of internal organization. So what are the parts of this internal data structure we will see. So here the port 1 is a simple input output microcontroller. Port 1 is dedicated only for simple input and output operation. It is addressed as 90H. It is addressed as a 90H. So it does not have any extra functions. These ports are not a multifunction. These are simply dedicated for input and output. Hence the output latch is connected directly to the gate. See here, one D latch flip-flop is here, and this D flip-flop is directly connected to the internal bus. This is the internal CPU bus. Here the internal CPU bus is directly interfaced to the D flip-flop. Then the complemented output of D flip-flop is connected to the field FET transformer. FET transistor. The output of FET transistor is connected to this 4 pins. Here 2 tri-state buffers are used. Here this tri-state buffer is used for read pins. What are the data in these pins? We can read by using these pins. If make high of these pin, we will able to read the data of these pins. And this is TB1, tri-state buffer 1, and this is tri-state buffer 2. There are totally 2 tri-state buffers are there, and the another tri-state buffer is used for read the latch. What are the output of this D flip-flop? We can read by using this read latch signal. The port 1 is simple input output operation, so it does not have any extra function. Hence the output latch is connected directly to the gate of lower FET. The output of latch is directly connected to the gate of FET. This is the gate terminal of this FET. The output of this D flip-flop is directly connected to this gate. And which is consisting a circuit labeled internal pull-up. This organization is used for pull-up operation. So port 1 as simple input port, how we can see. If I want to use this port 1 pin for write operation, I want to write something, means input operation. So what should I do? Simple, take one by one example. So we have to write, what we have to write? 1. So I am writing 1. Here if we give a high signal to this pin, the D flip-flop will provide 1 as the output and complemented 0. There are two outputs. So if I have given 1, then the output will become same as it is 1. This is the delay flip-flop, which takes a clock pulse and provides some delay and provides same outputs. So 1 is comes here Q output and complemented output Q naught, which is having inverted output. I have given 1. So in this terminal we are getting 0. So if 0 is fed to this gate, then this transistor acts as a switch here. If I have given 0 to gate terminal, this transistor will become off. if we provide zero signal or no signal to the gate, the transistor will become off. Then the transistor will become off. Then what will happen? The another terminal of gate is connected to VCC. VCC is nothing but high. So here a current is flowing. This will become off. And how is going? This high VCC current is flow like this. So here what will get in the output? 1. So port 1, for write operation to the port 1, we were providing 1 here, and it will give complemented output 0. 0 enter to this gate terminal, and this transistor will become act as a switch, and it will off on that state, and the high signal is provided on this terminal, cause that the current will flow. So the high signal will get on these port 1 pins. P1.x is nothing but port 1.0 to port 1.7. There are total 8 ports. So all these ports get high signal. Then the microcontroller acts as or performs write operations. So let's see how the read operation will be takes place here. For read operation, we have to configure these pins to low signal, or we have to feed 0 signal. Low. When we have connected these all the pins 0, then these pins are acts as a read operations. It will start reading or fetching the information. So how we can trigger these pins as a low? Just for the internal bus, we are providing low signal here. If we low signal provide here, the delay flip-flop produce the output as same low. Then the complemented output will provide 1. The 1 will comes here. After 1 comes here, the gate, the high signal, after getting high signal on the gate terminal of this FET, the FET will become on. The FET will become on. Then what will happen? After this FET will become on, then the current flow in this direction. The current flow like this direction. Here nothing output get on these pins. These pins remains low. So for the read operation, the low signal should be given to these pins. So how to read these pins? What are the data or what operation undergoing in these ports? How we can know? If we provide read pin high here, so what are the data is here? It will get by using these pins. And one thing is, remember that the output of Q is forwarded back as a clock signal to this same D flip-flop. This operation should be performed like that. For input operation, all the ports should become high. For output operation, all the ports pins should become low. So how the high and low signal will get inside these pin organization? How the operation will be takes place inside? We have seen here. Here one thing we should be remind that before doing read operation, we have provide or we have kept these pin of the port 1 should be high. It should be high. Why? Remember one thing, before doing read operation, all these pins should be kept high. So by doing instruction, how we can do? By writing the instructions. What? Set B P1.0. By executing this instruction, set B P1.0, what will happen? The pin P1.1 will become high. If I want to set all these pins at a time high, then another one instruction we have to execute. that is move port 1, comma, hash 0 FFH. The information 0 FFH means highest, or all the things are high. All the bits, high bits, we are moving into port 1. So by executing this instruction, what we are doing? All the pins are making high. Why we are doing this? So let's see here. If the 0 input CPU bus, the 0 signal get in this D flip-flop, then output will become 0, and here complementary output will become 1. After getting 1 on the gate signal of FET, the FET acts as a switch on switch. It will become on state. The FET will become on. So how the current will flow? The current will flow in this direction. So while reading, in read operation, we are going to provide high as well for reading the ports. I want to read these ports. What are the state of these port pins? So how I can know? If I have provided high pin to this, then two currents are flow here. One in this direction, another one is in this direction. There are two current will be flow. So what will happen? This transistor will become damaged due to high impedance, because in both the direction current is flowing. This is on state. So what will happen here? There is a chance to become damaged. So to avoid these damage of FET, we should keep this as high. If we kept high, what will happen? If we kept high, see what will happen here. So how to make these pins are high? I am giving high signal here. Output is also getting high, and here the gate terminal of FET will become 0. After getting 0 signal, this will become off. What will happen? This will become off. If I want to fetch these terminals, I am giving high signal to here, then what will happen? This become on. So there is no current flowing in this FET. So another current flowing here, then there is no any damage will get this FET. So that's why before doing read operation, one thing should be kept in mind. These pins should be kept high. So this is the port 1 structures details. So after that, let's see how the port 1 operation will be takes place inside the pin organization. So let's see. Here. This is port 1 structure. So what are the port 1 structure here? We have seen now operation of port 1. See, let's see how the port 0 will be performed. So port 0 structure. Here, the port 0 is a multifunctional port of the microcontroller of 8051. It can be used as a simple input-output mode, or for generating the data and lower order address bus for the external memory. Here, the port 0 will be used generating the data and lower order address of the external memory. The figure shows port 0 circuit. Its address is 80H and it is the bit addressable port. Port 0 does not have any internal pull-up, but Whenever port 0 is configured as an output port, pull-up is required. In order to use the pin of port 0 as the input, and the output of each pin must be connected to 10 kilo ohm. Pull-up register as shown in figure here we have given. These are the pull-up register. What we have to do? All the here all for all the ports, multiple or each for each port pin we have connected pull-up register in between the port pins and VCC. When port 0 is used as an input port, 1 must be returned to the corresponding port 0 latch. That will cause both the output transistor to switch off and the pin float in high impedance state. Hence, it is called as true bidirectional port because when configured as an input port is floats. When configured as input port, the microcontroller provides two facilities. First one is read logic label on physical pin by asserting read pin signal. Read the contents of internal latch by asserting the read latch signal. The latch is freed when instruction is read, modify, write type of instructions. Port 0 as simple output port. When port is configured as an output port, the latch pin that are programmed to 0 will cause the lower FET to turn on. The pin is grounded. If port 1 is written to 1, the latch pin FET will turn off and pin is pulled high by the external pull-up resistor. See here, this organization is used for accessing the operation address or data, or by using a control signal we can set the read and write, or for data transmission or lower order address. So these terms can be see here. Here is a multiplexer unit. This will use to trigger the what will get if the output pins should be act as a data bus or act as a address bus, or these port pins should be act as a input or act as a output. All these operations can be controlled by using this circuit structure. Here, if control signal becomes 0, then the port 0 pins used as a IO port. Here the total 7 pins in the IO port P02, P002, P07, which is act as data transfer pins. These pins act as either data transfer or it will act as a address transfer lower bit A0 to A7. This is act as a lower address transfer. If control signal C becomes 0, then these pins become IO ports. If control signal become 1, then these pin is used as address or data transfer bus. Address or data transfer. So see how the write operation will be performed by using this port 0. If I have given high to the internal bus, for write operation we should keep all the ports pin should be high. If high signal I have provided to this bus, then the output of D flip-flop will become high and the complemented output will become 0. Then what will happen? What will happen here? Here the gate, here what will happen here? This, for getting 0, this will connected to this gate. Then if C is equal to, instantly C is equal to 0. C is 0, C is 0, then the 0 signal will becomes here, then this will become off. This will become off, and the float output, there are two FET transistor is there. What will happen? Both will be, due to 0 here, this will also become off. FET1, FET2 both become off. Then here the float signal will be occurring. The floating of signal will be occur at the output. So to avoid these floating, what will happen? Here one resistor will be connected in between the pins and VCC. That resistor capacity is 10 kilo ohm. All these pins are connected by these resistors. To avoid the floating, so this output will become 1. When C is equal to 0, when C is equal to 0, for write operation we have to do high signal should be provided. For read operation, what will happen? For read operation, the 0 will be provided to this internal bus. The output becomes 0. Then complemented output of D flip-flop will become 1. And similarly, this is 0. Control signal will be kept 0. Then this transistor will get interfaced here in multiplexer. Then one high signal will be get here. And this FET will become on. This FET will become on. Due to 0 output from this AND gate, this will become off. The upper transistor FET will become off and the lower transistor will become on. So what is the output here? Due to on, how the supply will flow here? The supply will flow here like this. Because this one is connected to ground, the low signal will be occur at the output pins. So after getting low signal on these pins act as a read pins. Here, in order to use the pin of port 0, the input and output, each pin must be connected to 10 kilo ohm pull-up resistor. Here, these are the pull-up resistor which have connected in between VCC and each port pins. Port 0 used as a multiplex address or data bus for the external memory. When microcontroller accesses the external program memory or data memory, the address of memory is generated by the port 0 and port 2. Port 0 generated the lower order address A7 to A0, while port 2 generates a higher order address. Port 0 will generate a lower order address from A0 to A7, and port 2 will generate a higher order address from A8 to A15. When port 0 is used as an address bus to the external memory, when these ports are used as an address bus, then internal control switch the address line to the FETs. If logic 1 is written on the address bit, then the upper FET will turn on and the lower FET will turn off, providing a high logic at the pin. A logic 0 is written on the address bit, then the upper FET will turn off and the lower FET will turn on, providing a logic low at the pin. Once 8-bit address is been formed and latched by the address latch enable, the pulse into the external circuit, the bus turn around the data bus. The port 0 can now read the data from the external memory. For reading the data, it must be configured as the input port. This is the multiplexed data and address bus. When getting a high signal on address latch enable pin as well as it will become high, then the port 0 will act as an address bus. It will start accessing the address A0 to A7. As soon as the early signal goes off, then the port 0 acts as a data transfer bus for accessing the external memory. So these are the internal operations of port 0. We have seen port 1. So now let's see the operation of port 2. This is the port 2 internal organization. Here port 2 of microcontroller is multifunctional port. It can be used as a simple input-output port or generating the upper order address bus for the external memory. The port 2 circuit contains D type of latch, multiplexer, 2 bidirectional buffer FET, and output stage with pull-up. When port 2 is used as an input port, one must be written to the corresponding port 2 latch bits. This causes FET to turn off the pin and input to pin buffer are pulled to logic high by the internal pull-up load. Port 2 is called as a quasi bidirectional port as its output is pulled high with the pull-up resistor. Port 2 as a simple output port. When port 2 is used as an output port, the latch pins are programmed to 0. The latch pin should be programmed to 0 to use port 2 pins as the output port. When pause, the FET will become turn on. How the output is directly connected to here. Here. When the input pin of the latch will 0, then and similarly the control signal also high, then the switch is connected to the gate terminal of FET. Due to the inverter circuit here, the output high will be available at the gate terminal of the FET. Due to high signal on the gate, the FET will become on. The FET will become on, then the current will flow in this direction. Then 0 bit signal will available in port 2 pins. So the port 2 pins acts as a output port. When port 2 use an output port, the latch pin that are programmed to 0 will cause the lower FET to turn on. The internal pull up to the turn off and the input to the circuit is logic 0. If 1 is written onto the latch pin, then it will drive the input of external circuit high through the pull up. The lower FET turn off. The port 2 used as a higher order address bus 8 to 815 for the external memory. The port 2 pins are changed due to the address control signal. When it is supplying higher order address, the latch remains stable because it does not have to turn around the data input as in the port 0. So let's see the port 3. This is port 3. Here the port 3, all the pins are multifunctional pins in the port 3. It can be used as a simple input output ports, or the port 3 pins have special functions. The address is B0X and it is a bit addressable port. The pin P30 is it is receiver data pin or serial port for the receiver operation, and port 3.1 it is the transmit data pin for the serial port UART mode, and it works as the clock output in the shift register mode. And port 3.2 it is an external interrupt and it is low level or polling edge triggered, and P3.3 it's an external interrupt and it is low level polling edge triggered port. P304 pin of the port 3 it's act as a timer for counter operation. So there are two counter operations can be performed here, counter 0 and counter 1. So counter 0 operation, the T0 will be used, and T1 the external timer and counter operation. Here the pulse is given to TL1 register. Then P3.6 bright. This is the complemented low signal. Here what will happen? The external memory write pulse and also a active low pulse. It will trigger when low signal occurs on this pin. And read bar is also a active low pin. It is triggered and acts as a read operation when 0 is applied to this pin. Unlike the port 0 and port 2, where all the 8 bits simultaneously change for the alternate use, each bit of the port 3 can be programmed as a IO of to perform one of the functions listed here. Here port 3 contains also a D flip-flop. Port 3 also contains a D flip-flop and 3 unidirectional buffer FET internal pull-up, as the internal pull-up port 3 is also called as a quasi-bidirectional port. Port 3 is a multifunctional port. It can be used as a simple input and output operation. Here port 3 used as a simple input port. When port 3 is used as an input port, how? When 1 must be returned to the corresponding port 3 latch bit. And this causes the FET to turn off and the pin and the input pin buffer are pull up to high by the internal pull up low. When port 3 is used as an output port, the latch pin that are programmed to 0 and will cause the lower FET to turn on, the internal pull up to the turn off, and input to the circuit is losing 0. If 1 is written onto the latch pin, then it will drive the input to the external circuit high through the pull up. The lower FET will be turned off. The port 3, one of the alternate functions. For achieving any one of the alternate output function, another control signal called as an alternate output function is available on the port 3. Depending upon the logic level present on the line alternate output function, the FET will be turned on or off. When the latch bit of the port 3 is at logic 1, the output level of the control by the control input. The output buffers of port 1, 2, 3 can each drive 4 LS-TTL input. Port 0, when used in external bus mode, output buffer can be drive 8 LS and TTL input. In order to drive the input, these ports are port pins required external pull-ups to drive any inputs. This is the brief introduction about ports, all the ports. So in the next class, we will see the interrupts of 8051 microcontroller. How the interrupt will be structured in the microcontroller and what are the executing steps of the internal and what are the types of the internal, we will see in the next class. The next lecture.